All right, welcome to Hononegah Honors Algebra 2. This is going to be an overview of all of the sections in 9.1. So law of sines, law of cosines, SOHCAHTOA, right triangle, 45, 45, 90 special right triangles, 30, 60, 90 special right triangles. So again, this is an overview of all the stuff that we did in section 9.1. So here we go. There are going to be 6 right triangle trig ratios that you're going to need to know. You're going to need that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent, and then cosecant is equal to hypotenuse over opposite, secant is equal to adjacent, whoops, let me try that again, hypotenuse over adjacent, and then tangent is equal to adjacent over opposite. So again, the 6 trigonometric ratios, 2 area formulas that you learned. One area formula is the area formula using sine, so that's half AB sine C. So again, half of 2 sides times the sine of the angle in between. And then the Heron's formula, so I'll give myself a little space here. Heron's formula, you need S. So you need to know all 3 sides of the triangle divided by 2. And then the area would equal the square root of S minus A, S minus B times S minus C. So again, there's 2 area formulas you need to know. Law of sines. So the sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. And then I'm not going to write out all 3. I'm just going to do 1. So A squared equals B squared plus C squared minus 2BC cosine A. So again, those are all the different things that you will need to know and be able to apply as you go through section 9.1 here. I'm going to give you 1 trig ratio, and they want to know the other 5. And again, they don't want decimals here, and they don't want you to actually solve for theta. They just want you to give the ratios. So going to the picture here, this side would be 4. This side would be 11, because you're talking about the adjacent and the hypotenuse. Using Pythagorean theorem, so A squared plus B squared would equal C squared. Solving, so A squared plus 16 equals 121. A squared equals 105. A would equal the square root of 105. So now I know all the information that I need as I go through this. Sine would be opposite over hypotenuse. Tangent would be opposite over adjacent. Cosecant would be the opposite of sine. So we're talking about 11 over the square root of 105, which I need to simplify. Secant would be the opposite of cosine, so we're talking about hypotenuse over adjacent. And cotangent, again, I would have to simplify that one or rationalize the denominator. So there's cotangent, there's cosecant. So again, on your assessment, okay, you would need to be able to do all 5 of the 6 trigonometric functions. It's the right triangle, 45-degree angles. We're talking about, again, no decimal answers here. If I see a 45, 45, 90 triangle, I automatically write 1, 1, square root of 2. In this particular picture, you know one of the sides opposite 45 is x, the other side opposite 45 is 4, and the hypotenuse is y. Using the ratios, I'm going to set up proportions. Cross multiply. This one's easy. X would equal 4. And this one would be 4 square roots of 2. Cross multiply. Again, another 45, 45, 90 triangle. As soon as I see a 45, 45, 90, I write 1, 1 square root of 2. In this particular picture, opposite of 45 is an x. Opposite the other 45 is a y. And the hypotenuse is a 6. So again, setting up a proportion. And this will actually be the same answer for both of these proportions. I'm going to cross multiply. X times the square root of 2 equals 6. Now, this gets us into another, again, you have to simplify. Multiply both the top and the bottom by the square root of 2 and reduce. So 3 square roots of 2 will be the answer for both. x and y. 30, 60, 90 triangle, automatically write 1 square root of 3, 2. In this particular picture, opposite of the 30 is x, opposite of the 60 is 5, and the hypotenuse is y, setting up a proportion then. So 1 over x would equal the square root of 3 over 5, and then the square root of 3 over 5 would equal 2 over y. Solving x first, so x squared root of 3 times 5. I'm going to end up dividing by the square root of 3, which gets me 5 square roots of 3 over 3. Same with this one. Y times the square root of 3 equals 10. Divide by the square root of 3, I get 10 square roots of 3 over 3. So again, these two are a little bit more complicated than the ones maybe in the notes because I had to simplify the fraction. 30, 60, 90, again, 1 square root of 3, 2, giving myself some more space. Opposite 30 is 7. Opposite of the 90 is x, and this one's y. So 1 over 7 equals 2 over x. Cross multiply and solve. 1 over 7 equals the square root of 3 over y. Cross multiply and solve. So I know I went through those relatively quickly, but if you have any questions, make sure you talk to Ms. Kinsel or myself. Now, you're going to need a calculator, so I'm going to hit pause for a second so that I can get a calculator out here. And I'm back. So now, this is a right triangle, so we're going to use right triangle trig, which would be SOHCAHTOA. So sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So in this case, I'm going to do the sine of 32 is equal to x over 11. Multiply both sides by 11 and use my calculator now. 11 times the sine of 32 would be 5.8, rounding to the nearest tenth. Next one, I am given the adjacent, and the hypotenuse is what I'm trying to find. Multiply both sides by x and divide by the cosine of 55. So x would equal 21 divided by the cosine of 55 is 36.6. Now I'm going to try to find the angle measure. It's using the same ratios that I did before. This time tangent of x is equal to opposite over adjacent. Inverse tan to find the angle measure. So again, using a calculator, inverse tangent of 15 divided by 10. So then I get 56.3 degrees. Next one, sine of x would equal opposite over hypotenuse. Inverse sine of both sides to find x. So inverse sine of 5/12, so you get 24.6 degrees. So SOHCAHTOA, using SOHCAHTOA area formulas. Again, there are two area formulas that you need, that you learned in this particular section. One is dealing with sine, the other one is dealing with Heron's formula. Area formula with sine would be half one side, other side, times the sine of the angle in between. So again, typing that into your calculator, you should get 55.9 square centimeters. Heron's formula requires you to know S. S is be adding up all the sides and dividing by 2. So in this particular case, S is 13. And so the area would equal square root of S minus 6 times S minus 9 times S minus 11. And so take the square root of that, I get 26.98. So I'm going to round that to 27 square feet. So again, two area formulas. Now for the hardest part, law of sines and the law of cosines. And we're going to start off with a really tough one right off the bat. I'm given an acute angle, the side opposite of which is smaller than the side adjacent. So this is our issue. So if I angle A, C, B. All right, so there's the picture. That is the exact situation that might occur if you have two triangles. So give me a second here. I'm going to pause. Sorry for the pause there, and hopefully we're right back to going here. All right, so this is the situation that we were talking about with the law of sines, in which you have an acute angle. Side opposite is smaller than that of the adjacent side. So when I do the law of sines here, we're going to have a situation. So I'm going to do sine of 25 over 15 is equal to the sine of c over 18. Cross multiply and solve. So cross multiply and solve. Angle C would end up being 30.5. So hold on. That means there is an entirely second triangle, and I'm going to draw the picture over here that has the exact same situation, 25, 15, 18, A, B, and C, in which C is the supplement now. So angle C in the second triangle would be 149.5 degrees. So now I'm going to do these totally separate. So I've got angle C over here as 30.5 and angle C over here as 149.5. So the angle B on the left-hand side here, angle B would then be 124.5. And then the sine of 124.5 over B would equal the sine of 25 over 15. Cross multiply and solve. B on this side would be 29.3. So that solves all the different parts of the first triangle. Second triangle, angle B is now 5.5 degrees. And so the sine of 5.5 over B would equal the sine of 25 over 15. Cross multiply and solve. B would be 3.4. So again, you have to recognize this situation. Acute angle, side opposite smaller than the side adjacent. So then SSA. Next one. We have a picture here. A, B, C. Angle C is 75, side A is 5, and side B is 7. So I can't use the law of sines because I have no ratio, no angle with its side opposite. So C squared equals A squared plus B squared minus 2AB cosine C. Using my calculator, I'm going to do 5 squared plus 7 squared minus 2 times 5 times 7 cosine of 75. I'm going to get 55.83 square root of that, 7.5. Now I can do the law of sines. Sine of 75 over 7.5 would equal the sine of, now remember, you always want to use the smaller side when you have a choice. So I'm going to do the sine of A over 5, cross multiply, solve for A. Remember to take the inverse sine. You end up getting A to be 40.1 degrees. And then using all the angles need to add up to 180. So 40.1 plus 75. Angle B would equal 64.9 degrees. Draw a picture. A, B, C. 118 degrees. 10. Side A is 4. So now this would be the law of sines because I have an angle with its side opposite. So the sine of 118 over 10 would equal the sine of A over 4. We don't have to worry about the two triangle situation because our angle that we are given is obtuse. So remember, that is not the scenario that I gave you. Cross multiply and solve. Angle A would be 20.7 degrees. Once I know that is 20.7. The angles inside of a triangle have to add up to 180. So angle B would equal 41.3 degrees. And then the sine of 118 over 10 would equal the sine of, and I don't know B yet, so 41.3 over B. Cross multiply and solve. B would equal 7.5. So again, anytime I'm given 3 parts of a triangle, I need to find the other 3 parts of the triangle. 3 sides. All right, so let's talk about what happens when I'm given 3 sides. And my picture's not the best there, but side A is 8, side B is 15, side C is 17. When using the law of cosines, always go for the biggest one. So 17 squared would equal 8 squared plus 15 squared minus 2 times 8 times 15 cosine of the angle. Now, this is missed a lot. 64, 225, minus 240 cosine C. Subtract 64 and subtract 225. Now, that's a little bit of a tougher, I'm going to divide by negative 240. And some of you are going to think, so C is actually 90 degrees. Now, you actually have options here. Because C is 90, you can actually use SOHCAHTOA, but I'm just going to use the law of sines. Sine of 90 over 17 equals the sine of, remember, always go for the smaller one. Cross multiply and solve. A would equal 28.1 degrees using 180. So 90, 28.1, and then 61.9 degrees. So finding angle A, angle B, and angle C. Some of you are going to look at this, oh, this is a 2 triangle possibility. 75, 16. So it could be a 2 triangle situation. Let's try it. Sine of 70 over 5. Sine of 16 over, sine of C over 16. Cross multiply and solve. Uh-oh. When I go to solve this, 16 times the sine of 70 divided by 5, take the inverse sine. No solution. So it is impossible to draw this particular picture with, if you have a 70-degree angle with that side only being 5, this would actually not touch. So again, going back to our notes, this would be a situation where this could not be long enough to actually touch, and therefore there is no triangle. Last one here, you are given, whoops. So it looks like we lost this one, so I'll go ahead and write it in here. Angle B is 51 degrees. Side A is 9, and side C is 7. So now, law of cosines. B squared equals A squared plus B, A squared plus C squared minus 2AC cosine B. Using my calculator, typing all of that in, I end up getting 50.76, it looks like, 706. Take the square root, I get 7.1. So now, sine of 51 over 7.1 would equal, always try the smaller one, so sine of C over 7. I'm not showing much of my work. I'm going to cross multiply and solve. Hopefully you understand that at this point, and I get 50 degrees. And then all the angles have to add up to 180. So 50 plus 51 gets me 79 degrees then left over for angle B. You are going to need to still go over some of your word problems, things like that, and some of the stuff in the notes. Ms. Kensel and I spoke. We will do some type of assessment. We're not sure how that's going to end up looking like, but make sure you're going over this, make sure you're understanding it. If you do have any questions, make sure you contact Ms. Kensel or myself, but good luck on the assessment. Hopefully everyone's being safe and hopefully everybody's feeling well.